The first part of the question, which I did put in, right, was actually more of finding 2n r equals to 8, r plus 3 over r plus 4 factorial. Find this one. Are you all tested for this chapter? Yeah. Okay. This one can do, right? So, yeah, basically, you need to convert this to r and r plus 1. So this is the same as summation. Then change to r over r plus 1 factorial. Then because here you minus 3 here, you must plus 3. So it will become r equals 11, here 2n plus 3. Okay? Here to reach here is a minus 3, so here must be a plus 3. I think the original question, what happened is that they had a 2 some more, so it's a 2r plus 6. So you actually just bring out a 2. That was the original question. So that's why I say the first one I think y'all can do. It's at most y'all just forget. So the first part is actually can do. So that's why I want to focus on these two parts. Okay, especially the part 2. So now for part 2, and for part 1 first, I say y'all say cannot do, right? Let's go through this one first. Inequalities. Okay, need to show this. Show that x over x plus 1. Okay. Yeah, show that this is larger. Okay, let me pause first. Okay, it shouldn't be show. I used the wrong word. Make a mistake. It should be solve. Careless. Solve. Solve. My mistake. Okay, y'all try first. Okay, so from this one, without using a calculator, you can always use a calculator to check. So you can plot this, and then find the intersection. Okay, after that, from there, you can roughly guess the answer based on GC. Or you can also bring it all to one side. So for part 1, right, all you need is x squared plus x minus 5 over x. You just factorize straight. Minus x over x plus 1 less than or equals to 0. Okay, so the way to do is to form them into one fraction. Okay, don't bother factorizing the top one first, even if it can be factorized. Okay. So when put into one fraction, x plus 1, x plus 2, then here will be x squared plus x minus 5 times x plus 1. So it's x cubed plus x squared plus x. Then after that, x cubed plus x squared. Then plus x squared plus x minus 5x minus 5. Minus x, open bracket, x squared plus 2x less than or equals to 0. So you realize that there's an x cubed here that can be removed. There's also 2x squared here and a 2x squared. So we'll be removing these two. Okay, so makes things very easy now. You're just left with negative 4x minus 5 over x plus 1, x plus 2. Okay, now I don't like to deal with negative sign, although you can do it. So I will always try to turn it to positive first. So in this case, when you turn it to positive, you must remember to change your inequality sign.
So how do you get
4x. X minus 5x. X minus 5x. Okay. Now, from here, because you can see that this is going to be an x power 4 curve. X power 4 means it's going to be like this. And there's no repeated root, so we can just cut 4 roots. Okay, the roots are negative 1.25, negative 1, negative 2, and 0. So negative 2, negative 1.25, negative 1, 0. Okay, now there's an equal sign, so you need to be very careful here. But before that, okay, before being careful, we want to see where are the, where are the part where greater than 0. So you know it's going to be here, going to be here, going to be here. Okay. Now, if you are careless, normally you just straight away just don't think and just put like that. I just tell you first what some students will do. Okay, minus 1.25 x minus, don't copy this answer first because it's still slightly wrong. Okay, I'm showing you where the common mistakes are. Okay, there's a purposely make mistake here. So if you are not careful, when you see equal sign, you will go and put all the equal sign here. But that's not always equal. Okay, because the denominator cannot be equal to 0, man. All right. So you can normally it's not look at this one. Normally you'll look at the very front one. Just that in this case, it's going to be the same. So at the very front right here, you can add in that x is not 0 to negative 2 or negative 1 from the very front part. Okay, and then as you solve the final answer, then you can refer to this. So 0, negative 2, negative 1. I mean, x cannot be 0, negative 2, negative 1. So you look at this equal sign. There is an equal sign here. So cannot. Okay. So what all you need to do is just to remove the equal sign. And then after that, equal sign only for negative 1.25. Okay, because the rest all cannot be 0. Okay, so this will be the answer for part 1. Okay, Ken, good. Okay. Until here? I will zoom out to let you copy first. Hope you all recall the inequality area. So the whole answer is here.
Teacher, I had a question.
Yeah.
How do you know that there are 4 intersections?
How do we know the number of point of intersection?
Yeah.
The number of point of intersection comes from this part. You can see that it's x power 4. So there must be 4 roots.
Well, where does the x power 4
in this
come?
case, again?
Where does the x power 4 come from?
Okay. So the thing is, you all learn from school to solve from year to year. Okay. Some of y'all I teach before, but I don't know y'all remember or not. Okay. Why is it that we can solve like that immediately? It's because we actually multiply by the square of this. You see, when you multiply by x, we can't do it. We can't just say 4x plus 5 greater or equals to 0 because we don't know the denominator greater or small, whether it's that we are greater than or smaller than 0. But when you multiply by squares, they are always greater than 0. So in a way, what happened is that 4x plus 5 over x plus 1, x plus 2. Okay, we know it's greater or equals to 0, right? So imagine what happened is that you are multiplying this part. Okay, you multiply with. Okay, maybe I shouldn't do this. Okay, let me rewrite. Let me find another space to write. So let's say you are taking 4x squared. 4x again. 4x plus 5. Okay, so if we multiply, right? X plus 2. Now, imagine you multiply by this. X square, x plus 1 square, x plus 2 square. It will still be greater or equal to 0 multiplied by x square, x plus 1 square, x plus 2 square. You multiply this on both sides of the equation. Because we are multiplying by the squares. So you can know that it's always positive. So that's why no change in sign. As a result, right, what will happen is that you'll get this final equation. This was actually the way that we did in the past, but now they simplify it. So when you ask, where do you get the x power 4? This is how you get the x power 4. This is how you manage, you can manage to get this. But to simplify, okay, the working, the schools all teach from year straight to year. Okay, you can also do this at the A level. It's allowed. Okay, but the reason is because of this. Okay, the other side is 0, so no diff. Okay, so you can see that, I mean, you'll still get the same roots. So that is why we don't need to do this additional step. It's sufficient to go from year to year. So that is the reason for this. Okay, right?
Thank you.
Okay, so inequalities, recap already. Okay. Copy finish? Okay. So now part 2. The main thing wasn't to teach part 1, was to teach part 2. So for part 2, hence show this. Now we are given this summation. I mean, part 1 is also to do this summation, but you can see that there's no link to this part. Okay. So the question now is, how do we then start this thing? So I tried to explain earlier to the Tuesday class. There was a problem where I tried to explain the thinking. They cannot see why. Okay, I hope you all can see why today. So I give the solution first, which of course you won't understand why. Because when you see such a solution, normally it's like you see the solution. So you won't think of like, you'll be thinking normally it's like, how do they even think of this? That is where the other part comes in, which I will be trying to explain. Why is it that you can think of it? Okay, those are usually the side workings. You won't see in exam one. You won't see in the word solution one. Okay, but these are the things you need to go through your head. You need to do on a rough paper before you get your first line out. Then those who are looking at just at the solution will look like, hey, it's very magical. How come you can think of this? But there is a reason. It's a very systematic process. Okay. Okay. So now this one a bit. I'll reopen the question again. Okay. So this one is just remember this one is going to be solved. Okay, and we solved it already. So now hence show this. So now we know this to be true. Okay, you can solve means it is possible. And not just it's possible. Okay, this R equals to 1 is going to play a role. So you can see that this is true. Okay, when the answer is, let me find the answer again. We need the answer here. X smaller than -2. Then minus 1.25, x1, and x greater than 0. As long as x is positive, this will be true. The hence then come from here. So you need to try and observe. Now, normally, when it is smaller, right, it means that this summation is smaller than another summation. It's like that one. So it's like, okay, before that, we understand this one first. You can see that this summation here, immediately, I hope you all can see that this is less than 1. Because this one is always positive. 1 over n plus 1 is in factorial is always greater than 0. So 1 minus this will always be smaller than 1. Make sense, right? Cannot? I also can prove. Cannot? Okay, so we know that this is smaller than 1, and now you want to prove smaller than 1. Immediately, right? Normally, it will be always you are trying to show that this blue color box is smaller than this red color. Because if this is smaller than 1 and this blue color is smaller than this one, then this must be smaller than 1. That is usually the trick. Of course, they can change the number to 2.5 somewhere. Numbers change here and there. It is still possible. Okay, then just small tweaking only. But this is the standard one. The more complicated it looks like, the more simple, the simpler it actually is. Okay. So we know that we want to compare these two. And we know that this must be smaller than this. Not all the time, but it's slightly most of the time. Okay. So what I will do usually is I will do something like this. I will write down as this is my side working. Okay. So you won't see this. I hope you all understand this answer. So later when I do, then you will see why. So what I want to do, right, is I want to compare this. Compare this without the summation. Compare this against r over r plus 1 factorial, which is the top part without the summation. Although we know that it must be smaller than, but now I want to put versus just in case it's not. Then you know there's a mistake, then you need to try again. Don't fix a smaller than. Okay. Now, when you want to do comparison, okay, when you want to do comparison, we try to eliminate those that are the same on both sides. Okay. So now what happens here first is that I'm going to convert this r plus 2 factorial into r plus 1 factorial times r plus 2. Okay, so essentially you are going to compare, you change back to red, r plus 1, r squared plus r minus 5 over r plus 2, r plus 1 factorial. Why I do this is because there's an r plus 1 factorial. Okay, now, I mean, I'm quite sure you all can see this r squared plus r minus 5 is related to this one already. So we want to try to bring this in later. Okay, you can see if it's sub x as r, it's actually inside. So because this r plus 1 factorial is the same on both sides, essentially what we want is we are going to compare which one is larger. Correct? And because of this r, right? I'll put an r here, then I'll put a square here. Now, I will compare this versus the value of 1. Not all the time going to be 1, just that I can erase this. Okay, sometimes it may be comparing with another obvious polynomial. Okay, so now that we have this, now we want to try and fit in this one already. Okay, you can see that r squared plus r minus 5 over r squared plus 2r. Can see inside, right? So if you can see that this thing is the same as r plus 1 over r squared plus r minus 5 over r plus 2 versus 1. Okay, this is same as x, correct? And then this one is just the inverse of the x over x plus 1. Okay, so now you already can know that r squared plus r minus 5 over r plus 2 versus r over r plus 1. And this is obvious that based on this, we want this to be smaller than. Yeah. Because you can just inverse this because r greater or equals to 1. So r is always positive. R plus 1 is always positive. You can bring them around without, you can bring this r and r plus 1 to each side without changing the sign. But you need to say this. Okay, we need to emphasize on this and we need to emphasize on this. Okay, so far? So, I mean, this part you can understand, right? You won't see the link yet. I'm going to show you the link. Then we'll revisit this part. Okay, now, okay, I understand the link. So now you will see that what I'm going to do, this is actually our intention. This is actually where we are going to start our working. So when I do this, right, I'm actually working backwards, we are actually going to start the working from this last part and work our way up. And then finally we solve it. Okay? Up to you, okay? Now, let me open a blank page again. Okay, where's my blank page? Okay, so now we are going to start the working. So we know that at the start, r squared plus r minus 5 over r plus 2 is smaller or greater? Smaller. Smaller or equals to r over r plus 1. Because r greater than equals to 1, which is greater than 0. Okay, so we make use of part 1. Then from here, we can continue. R plus 1, r squared plus r minus 5 over r squared. Actually, we can just leave it. We can just leave it. I mean, you want to do r squared also can, but I will just do it this way. Smaller or equals to r. Again, because haven't finished. Because r great we bring wait, let me see. I should leave it there. Because r plus 1 greater than 0. So this is explaining why no change in sign. Okay. Now, next part. This is the solution you will normally see in exams. So we multiply we divide by r plus 1 factorial on both sides. Again, no change in sign because r plus 1 factorial greater than 0. Okay. So now this one is your r plus 2 factorial. In fact, you may even ignore this equal sign because greater or equals to 1. It's only equals to 0 when it's greater than 0. Okay, they are equal when r equals 0. Okay, so it's actually positive when this is not equal to 0, but we can ignore because for this case, for this particular question, no need. So now this is what we want to prove, and we reach here. Then your last part, you add in a summation sign. This is exactly the question, almost the question already. Okay, so now that you get this comparison, okay, so since the summation of r over r plus 1 factorial less than 1, therefore, the summation of this entire r plus 1, r squared plus r minus 5 over r plus 2 factorial less than 1. So you see, you're making a mathematical argument. Okay, now let me zoom out a little bit. Then we do our comparison here. The thing is, just imagine if you are doing this immediately, you'll be thinking, hey, how come I know must multiply? How come I know I must do this and bring this over only? Okay, if you realize this is actually working backwards from here. We started from this one. Okay, let me erase this part. We started with this, and then we work backwards. Just that I didn't want, I mean, I can work backwards to r square here, just that I didn't want to change the r over. Okay, so I changed a little bit, yeah. Of course, I changed a little bit. Okay, if we want to bring here to become 1, also can. Then r squared, then multiply on both sides. Okay, so if I want to be exactly backwards, that's not what I would have done with this. I would have used this to be 1 and just multiply by another r here. Okay, so here will become r times r, right? Then after that, I will multiply by r over r plus 1 factorial on both sides. And you will still cancel them out. So it is actually working backwards from this to this to this. Finally, you'll see that in this third step, you can see that I cancelled away r plus 1 factorial. That is why in my third step, I multiply back r plus 1 factorial. Okay, the earlier part where they were all the same, because the inequality is not based on what is the same, correct? So but all the same one, all the similar one, we cancel out first. We compare the difference of the remaining. Then as we work back to get our answer, now we multiply back the same stuff on both sides of the inequality. Okay, and eventually we'll get our nice inequality, which we can add in a summation and finally solve it. Okay, it's not like suddenly you will just think of it one. No. Okay, you need to follow this system.